Alright, so today we're going to talk about a concept called undefined fractions. Undefined fractions happen when you have variables or equations in the denominator or the bottom of a fraction. And to really understand what an undefined fraction is, we're going to do these few warm-up problems together. First, if we just divide 6 by 3, 6 divided by 3 gives you 2. The way you would check your answer is to multiply 2 times 3. Sure enough, when you multiply 2 times 3, you get 6, so it checks. Now, if you had a calculator and you divided 0 by 4, 0 divided by 4, in fact, 0 divided by any number is just 0. To check your answer, you'd multiply 0 times 4, and sure enough, 0 times 4 is 0. But what happens when you divide 8 by 0? In other words, what happens when you have 8 in the top of a fraction and 0 in the bottom? 8 divided by 0. Well, if you went to your calculator and you typed in 8 divided by 0 and hit enter, this is the message you would get. Sometimes it says error. Sometimes it says divide by 0, error. And when we come into class tomorrow, I'll have you check and see what our new TI Inspire calculators say. Sometimes it simply says undefined. So in conclusion, dividing by 0 is what we call undefined. Basically, if you ever have 0 in the bottom of a fraction, you have a fraction that's considered to be undefined. A fraction is undefined when the expression in the denominator is equal to 0. So please don't make these any harder than they need to be. These are really simple problems. It says determine when the following rational expressions are undefined. Again, they're undefined if the bottom of the fraction is equal to 0. So in this first one, the bottom of the fraction is x. Well, what would x have to be for the entire fraction to be undefined? X would have to be 0, because then you would have 3 divided by 0, and since 0 is in the bottom of the fraction, that fraction's undefined. For number 2, what value of x would make the bottom of this fraction undefined? Well, you just thinking about it, you might think, well, I know that 5 minus 5 is 0, so I guess x equals 5 is the value of x that would make that entire fraction undefined. And that one was pretty simple. But here's a sure way of getting the correct answer when you're asked for what value of x makes a fraction undefined. All you have to do is take the bottom of the fraction, set it equal to 0, and solve the resulting equation, because that's going to give you the value of x that gives you 0 in the bottom of the fraction. X equals 5. Now you got to be careful with the x squared. We've talked about this before. If we were to take x squared minus 25, the bottom of this fraction, and set it equal to 0, and solve for x, to get the x by itself, we would add 25 to both sides. That would give us x squared equals positive 25. And we talked about how the opposite of squaring is square rooting. When you take the square root of both sides, you get x equals 5, because the square root of 25 is 5. But there's also a second value of x that's true. Remember, not only is the square root of 25 positive 5, but the square root of 25 is also negative 5. And you can check it. If you plug in x equals 5 here, you'd get 5 squared minus 25, which would be 25 minus 25, or 0. It would make the whole fraction undefined. If you were to plug in x equals negative 5, you would get negative 5 squared minus 25. You know that negative 5 squared is positive 25, and again, 25 minus 25 would give you 0. So for this number 3, there's actually 2 values of x that make the fraction undefined. Now this one's different because it has an expression in the top that has an x in it. But don't worry about that expression. An undefined fraction has nothing to do with what's in the top of the fraction. You just have to worry about what's in the bottom. In the bottom we have a 6x. Well, what value of x would make this fraction undefined would be the value of x that sets this bottom equal to 0. To solve for x, you would divide both sides by 6, and 0 divided by any number is just 0. So it's x equals 0 that would make this fraction undefined. In number 5, I don't care that there's an x in the top. I'm going to take the 4x plus 2 and set it equal to 0. And when I solve this equation, set equal to 0, I will then know the value of x that makes the fraction undefined. Subtracting 2 from both sides, I get 4x equals negative 2. Dividing both sides by 4, I see that x is negative 1/2. So the value of x that makes this fraction undefined is negative 1/2, and that's because 4 times negative 1/2 is negative 2, and negative 2 plus 2 is 0. Now 6 is interesting. What value of x makes 6 undefined? None. The bottom is a constant. 7 is a constant number. You can never change 7 into 0. You have to have a variable in the bottom of the fraction in order for a fraction to even have a possibility of being undefined. If there's a constant in the bottom of the fraction, that fraction will never be undefined. Now sometimes these questions are asked in a little bit of a different way. Here it says determine any restrictions on the equation below. We're not going to solve anything. We can work on that tomorrow. I just want to determine if there's any numbers x cannot be. Obviously those would be the numbers that make the fraction undefined. This is an equation. We certainly could cross multiply to solve it, but again, right now we are just looking for the numbers that make this equation undefined. Well, on this side, what would x have to be for this side of the equation to be undefined? Well, x cannot be 0, because if it were, we'd have a 0 in the bottom of the fraction, and that fraction would be undefined. For this side, x cannot be 2, because 2 minus 2 is 0, and that would make this fraction undefined. So x can be any number except 0 and 2. For number 8, on this side, x cannot be negative 2, because negative 2 plus 2 would give you a value of 0 in the bottom of that fraction, making the fraction undefined. For this side here, x cannot be positive 4, because 4 minus 4 would give you 0 in the bottom of this fraction, making that fraction undefined. So in order to solve this equation at all, you need to state that x is not negative 2 and x is not 4. For number 9, it doesn't matter what's in the top. Doesn't matter at all there's an x up there. What value of x would make this undefined? It would be the number that when you add it to 2 you get 0. That's negative 2. So the restriction here is x cannot be negative 2. For this one, x cannot be negative 3, because negative 3 plus 3 would give you 0 in the bottom of the fraction. For number 12, x cannot be negative 5. And that has nothing to do with this part up here. Doesn't matter what's in the top. X cannot be negative 5 because negative 5 plus 5 would give you 0 in the bottom, making that fraction undefined. And for this one, notice you have a constant in the bottom on the left side, you have a constant in the bottom on the right side. So x can be any real number, because the x's in this equation are in the top, and the top doesn't make a fraction undefined. So remember, when there's constants in the bottom of a fraction, you don't have to worry about any restrictions. So let's consider one more. Take a look at this equation. You haven't learned how to solve this type of equation, but we should be able to make some generalizations about the solution set. You might be saying, oh, I know how. I know how to solve this, Miss Edwards, because all I have to do is cross multiply. But if you were to cross multiply and do, for example, x plus 8 times x plus 4, when you double distribute, x times x would give you x squared. And you see, no, guys, you haven't learned how to solve equations with x squareds in them. We're only learning how to solve linear equations so far. But letter A says, is x equals 5 permissible? Meaning, could it be in the solution set? Well, it could be if it didn't make either side undefined. So if I plug it into the bottom here, if x was 5, I'd get 5 plus 8, which is 13. Well, 13's okay for the bottom of a fraction. That doesn't make a fraction undefined. It would have to be 0 in the bottom of the fraction to make it undefined. For this one here, if I plug in 5 for x, I get 5 minus 3, which is 2. 2's okay for the bottom of a fraction. So is x equals 5 permissible? Yes, it is. Because x equals 5 gives you a denominator of 13 for this fraction, and it gives you a denominator of 2 for this fraction. 13 and 2 are okay for the bottom of a fraction. 0 is not. Which values of x would be excluded from the solution set? Well, let's take a look at this bottom here, and let's take a look at this bottom here, and think about what value of x would make x plus 8 equal to 0. Well, x cannot be negative 8, because negative 8 plus 8 would give you a denominator of 0, and you cannot have 0 in the bottom of the fraction, because the fraction would be undefined. For this side, x cannot be 3, because 3 minus 3 would give you a denominator of 0, making the fraction undefined. So be ready to come in tomorrow and we'll practice this skill.